The ability to be a door and the ability to glide are like opposite ends of the excitement spectrum, but both are extraordinary adaptations found in arboreal ants. Today, we're talking about doorhead ants and gliding ants. I'll tell you why they exist and how they work. Let's bug out. Doorhead ants are these guys, and they exist to protect their colonies. They're a critical part of the arboreal ant lifestyle because of the way that these tree dwellers make their nests. They don't have sand to dig into and excavate up in the treetops, so instead, they find pre-made cavities left behind by other arthropods, usually beetle grubs. But of course, beetle grubs are much larger than ants, and while that means the inside of their colony is nice and roomy, it also means that the entrance to their colony is enormous, making it very hard to defend from threats. So, how do you close an enormous doorway? With an enormous door. Doorhead ants are full-time living doors. They exist to defend the entrance to their colony using their own body. Side note, this kind of behavior is called phragmosis, and ants aren't the only ones who do it. Different species of frog, spider, and aphids are also known to have specially adapted body parts that they use to protect their homes. So cool. Now, the wild thing is that it's not just soldiers putting their heads on the line. In some species, every single caste has this ability. In other species, it's primarily a queen. It all depends on the specific pressures that led to their adaptation. And this is something so amazing about the doorhead adaptation. It's not specific to one species or even one genus. It's a case of parallel evolution across genera, meaning those genera evolved the doorhead adaptation independently from one another, like the Southeast Asian capybara and the Afrotropical capybara. They don't share some door-headed ancestor, they don't share a continent, but they reached the same adaptive conclusion over time. So cool. So, okay, we know why these ants exist, but how? How do they work? Well, that phragmatic head really is their head. That disc is above their eyes, mandibles, antennae, and other sensitive bits to protect them in case of an attack. But they can and do take damage to that disc. Scientists find these little guys with missing chunks all the time. One scientist, and this is kind of sad, used a pen to push on an ant to find out how much pressure it would take to actually move it, and the answer is no amount. The ant will stay braced in place even if it means their head gets punctured, because these ants don't have a lot of other defenses. But this is where their specialized camouflage ability comes in. After all, things won't attack you if they can't find you. Some species have special Velcro-like hairs on their head that they use to collect debris like moss, wood bits, whatever, helping them blend into the tree. Other species, like this one, make their camouflage. You see all of those little dimples across the surface of the head? Well, they use those to excrete fibrous material that creates the same effect as collected debris. So amazing. So, okay, that's the part about being a door. But how about the fact that many of these species can also glide? And I don't just mean fall without getting hurt. That's true for most ants. I mean intentional, directed gliding that lets them hit their target 85% of the time. Why have they learned to do this? Well, for these arboreal ants, it's a matter of life and death. Because let's say they couldn't glide. Best case scenario, they survive the fall, they land on a nice dry forest floor. Then what? They can't find their way back to their colony without chemical scent trails nearby, and a single ant is a pretty tasty and easy snack for almost anything. So while the fall itself may not mean the end, the consequences for being out of the tree are severe. Now, the natural next question, how do they do this? Well, back to the shape of their bodies. These ants are kind of wide and flat, which helps slow their fall while they're in the air. They're also very flexible, which lets them move their body around in the air like a rudder. But more importantly, these ants have learned how to do two things. One, the precise angles needed to steer, and two, how to recognize their tree trunk. As they fall, they look around for the pale column that is their tree. Once they visually lock onto it, they angle their body just right to swoop and land. In experiments, scientists found that their fall pattern was really consistently J-shaped. As they fell, they took their time to look around and then swooped once they were confident. They also found, adorably, that these ants steer and lead with their abdomens, meaning they come flying in butt first. All right, friends, this is my first longer form video, so let me know what you liked, what you'd like to see different next time, and feel free to suggest topics in the comments. Also, if you like bug facts and vintage entomological art, check out my Postcard Club. Every month, I select a new bug to highlight and mail it out in a cute little envelope. Thanks for being here, and keep looking for the little things.